Now let's see how to differentiate tan x with respect to x using first principle. Now much easier procedure is to write tan as sine by cos before I can increment x and y. So let me do this as the first step, and let us move with the first stage of the problem as I said. So increase x with as x plus delta x and y as y plus delta y. Now let's go. I can write y plus delta y as equal to sine of x plus delta x divided by cos of x plus delta x. Well, that's fine. So what is that I have to do? I have to keep delta y on left hand side and put everything on the other side, right? So delta y would be sine of x plus delta x by cos of x plus delta x minus, taking y on the side, that is minus y. So what is y? Y is, you can say it's sine by cos. So let me write this. So delta y would be given as sine x plus delta x by cos of x plus delta x minus, I can write y as sine by cos. So sine x by cos x. Now, as we see, what's the problem telling me? There are two fractions. So I told you before also, when I have two fractions, the first thing I should think is to take LCMs. So let us take the LCMs. That is denominator goes like cos of x plus delta x into cos x, and the numerator goes like sine of x plus delta x into cos x minus, I can write cos of x plus delta x into sine x. It's simply cross multiplication this here, right? Now, I need to know one formula here. This is from your allied angles. We have compound angles, right? That is sine of a plus b is given as what? It is sine a cos b plus cos a sine b. There's a very simple formula we have to use here. So this guy looks like sine a cos b and cos a sine b, where this whole thing can be taken as a and this as b. Alright? So if I use this formula, sine a cos b cos a sine b becomes sine of a plus b. If I employ it here, it goes like delta y is sine of a, that is x plus delta x minus this time, because if it is a plus here, it's a plus here, and if it's sine of a minus b, it goes like sine a cos b minus cos a sine b, isn't it? Since there's a minus here, I take sine of a minus b. Who is b? B is x, divided by, this whole thing reduces to sine of a minus b, which goes as sine a cos b minus cos of sine b. That's it. Now what's the denominator? Cos of x plus delta x into cos x. And that's what I have. Now we'll see what happens. Can I write this as sine delta x divided by cos of x plus delta x into cos x? Yeah. That's my first stage. Second stage is what? Remember, I need to divide both the sides by delta x. That's right. So I have delta y by delta x. Let me write this as sine delta x divided by cos of x plus delta x into cos of x divided by delta x. Right? I'm dividing delta x on both sides. Now, what is the next thing I should think? It's very important, is I should make sure that there is no delta x on the right hand side in the denominator. So now I need to somehow eliminate delta x. I cannot cancel anything because this delta x is inside sine. So again, you should go with that formula. Remember that? Limit of delta x tends to 0, sine delta x by delta x is 1. Or if theta tends to 0, sine theta by theta is 1. So whatever design here, it should be same. I can see that sine delta x and delta x is there. The design is still there, right? So I just need to write these two guys together and see how it works. I'll take this part of the board. Now, look at this. If I write this as delta y by delta x goes as, let me write this on this side itself, that is cos of x plus delta x into cos x. Let me write sine delta x by delta x. They are multiplied, so I can just write them separately, no issues. Now, the third stage comes now. What is the third stage? It says to apply limits on both the sides. So let me write this as limit of delta x tends to 0, delta y by delta x. That should be equal to limit of delta x tends to 0, and I'll write the first part, that is 1 by cos of x plus delta x into cos x, and limit of delta x tends to 0, that is sine delta x by delta x. Correct? So I hope you can see this. I'm writing really small. Now what happens here? This guy looks like that formula, right? So this whole thing becomes 1. So what is the next thing? And this looks like what? dy by dx. And let me apply the limit little later here. Limit of delta x tends to 0. What is left out? That becomes 1. So that becomes 1 into 1, and this is left out. That is 1 by cos of x plus delta x into cos of x. Now when I apply this limits into wherever I have delta x, substitute 0. So what I get? dy by dx is given as 1 by cos of x plus 0 into cos of x, which is nothing but cos of x into cos of x, which is dy by dx can be given as 1 by cos squared x, which is cos squared goes up, it is secant squared x. That's my answer. So I can understand that differentiation of y is equal to tan x is nothing but dy by dx would be nothing but secant square x. So I understand how to do this. Alright.